Right, so here is another question. It says, within 0.04 seconds of the car hitting the back of the lorry, the car driver's airbag inflates. The airbag deflates when it's hit by the driver's head. Use the idea of momentum to explain why the airbag reduces the risk of the driver sustaining a serious head injury. So, because it's to do with momentum, it's to do with forces, we're going to use the equation force equals change in momentum divided by time. And we use that to help us to write a description. Okay, so we can say that let's get the exact answer. So we can say airbag increases the time, just there, the time, because we're using the equation, it takes for the momentum of the head of the person to decrease. Okay, so what happens is the airbag changes shape as it deflates, and it increases the time it takes for the momentum of the head to decrease. This will reduce the force on the head, so reduce chance of injury or risk of injury. Okay, and it's as simple as that. So you'll get 1 mark for saying it increases the time, and you get 1 mark it takes for the momentum to change, and as a result this reduces the force, and if you have less force on your body you reduce your chance of injury. Now let's have a look at what this would be like in a calculation. So if we have a look at this, we can see figure 2 shows a child on the playground swing. The playground has a rubber safety surface. A child has a mass of 32 kilograms, okay, and they jumped from the swing. When the child reached the ground, she took 180 milliseconds. Now that has to be converted, so underline that so you don't forget to slow down and stop. During this time, an average force of 800 newtons was exerted on the ground. Calculate the velocity of the child. So before we do that, we're going to have to use our ultimate weapon. Okay, so our ultimate weapon, don't forget, is kilo, mega, giga, tera, and then milli, micro, nano, and pico. Okay, and then we remember that times by 10 to the 3, then times by 10 to the 6, then times by 10 to the 9, times by 10 to the 12. And then we do these the opposite, times by 10 to the minus 3, times by 10 to the minus 6, times by 10 to the minus 9, and times by 10 to the minus 12. We've got milli, so we're going to have to use times by 10 to the minus 3 when we get round to it. Now this is worth 5 marks, so it's going to almost certainly use 2 equations. So we're going to see FIFA, it, just here, like so. Now, it's asking us to calculate the velocity, and this is to do with momentum because we're given mass, we're given time, we've got force, and it's to do with people hitting the ground and their momentum changing. So it's going to be to do with momentum. So we write the equation out for momentum. Momentum equals mass times velocity, and that's what it's asking for, the velocity. So, and we're given the mass as well. First of all, before we start though, we want to sort out our conversion as well. So we want to do 180 milliseconds. So we can do 180 times by 10 to the minus 3, okay, is our conversion. And we don't have to do any more, that's it done. We just put that into a calculator. Okay, we could just say is equal to 180 milliseconds, like that. So then what we do is we put our numbers in. So we don't know our momentum, but we do know our mass is 32 kilograms, and we don't know our velocity. That's what we're trying to work out, so I put a double line underneath it. Now, we need to work out momentum, otherwise we can't work out velocity. So that means we need to use another equation. So we see phi for it again. Now we've already done our conversion, so we don't need to convert again. Okay. Now we want to work out momentum, so there is another equation for momentum, as you should know. So momentum equals, force equals change in momentum divided by time. Okay, and then all we have to do is put our numbers in. So if we put our numbers in, we've got a force of 800 newtons, and that equals our change in momentum, which we don't know, so we put that there, and our time is 180 times by 10 to the minus 3, like so. Now what we want to do is just get momentum on its own. Okay, so we're dividing by 180 times 10 to the minus 3, so if we times by 180 by 10 to the minus 3 on both sides, that gets rid of that. So we end up with 800 times by 180 times by 10 to the minus 3 gives us our momentum, which we can use up here. So what we do is we get our calculator and we do 800 just there times by 180 times by 10 to the minus 3, and that gives us 144, which is a reassuringly nice number. So our answer is 144 kilograms meters per second. Okay, because that's the momentum we want. And then we can put that into our equation. So we can have 144 equals 32 times by v. Then all we have to do is rearrange it for v. So it would be 144 divided by 32 gives us v. And that would be our answer. So we've already got 144. We divide that by 32 because that's our mass. That gives us 4.5 meters per second. Okay, which is 4.5 meters per second, which sounds about right. Hopefully that helps, and that is your final answer.